So I'm going to talk about data analytics at Bleacher Report and kind of working in the sports stuff. It's a whole new ball game. I was also pointing out that there is a ball game going on now too. So like Joe said, I'm the lead platform, I lead the platform analytics team at Bleacher Report, which sounds really impressive, but until May, that was a team of one. I thought I'd also start out with 3 maybe interesting facts about me. I don't have a traditional computer science background. I have a PhD in computational biochemistry. So that leads us to my second interesting fact, in that while I've given science talks, this is my first external tech talk, so be kind. And third, currently I am on maternity leave, so if I seem a little loopy, it's probably due to lack of sleep and chasing after these 2 guys. So what is Bleacher Report? It's a digital media sports site. It was launched in 2007 by 4 friends from down in the valley. The focus of the articles are on teams and topics. It was an interesting concept because initially all the articles were crowdsourced, kind of Huffington Post style. So it was, kind of by the fans, for the fans. But as the company sort of matured and evolved, we've recruited a little more professional writers, and our reputation has vastly improved since '07. Let's see, in 2012, we were acquired by Turner Sports, and in January 2013, we became the sports news provider for CNN.com. So that's all really exciting and important, but what really showed me that Bleacher Report has made it is that December 2012, we got parodied by The Onion. If you've never visited Bleacher Report before, we have kind of a reputation for lots of slideshows that rank things. So they wanted a slideshow of ranking Tom Brady's top 10 fingers. Just to kind of show how much our popularity has increased, I started in May 2011, and I was told that we're a top 5 sports website, which means we are number 5. But this past year, we've moved up, according to ComScore, which is how we all sort of evaluate ourselves. We've moved up to the number 2 spot. We lost it again a couple months ago, but we're constantly, battling Yahoo Sports for the number 2 spot, and we're eventually moving closer to passing up ESPN.com. Another great metric is that in 2014, our mobile app, TeamStream, became the highest viewed sports app in terms of minutes spent in app. I can't really see, but it shows TeamStream number 1, and then ESPN Sports Center was number 2. So we're significantly ahead of them. There's a site, NewsWhip, which sort of aggregates social analytics. And in 2014, we were ranked 6th as the 6th largest Facebook publisher. And that's sort of including likes, shares, and comments. And we are the first standalone sports website to reach such a high position. And we are ranked 9th in Twitter by NewsWhip. So those are kind of our rankings. What's some interesting numbers for traffic? Our 31-day trailing period, we've had a high of 84 million unique visitors, over 315 million visits, and 1.6 billion page views. This occurred, I think all of those metrics occurred from mid-June to mid-July, when we kind of caught the tail end of the NBA Finals and the beginning of the World Cup. So obviously lots of people come into our website. We've had a daily high of over 90 million page views, and that occurred the day after the start of the NFL draft. We have a lot of great commentary and analyses of the draft orders. And then we've had 232,000 simultaneous users, and that was when LeBron made his announcement that he was going to return to Cleveland. And then here's from, oh, you don't see my mouse, but the graph at the bottom is our users from Google Analytics, and you can kind of see how we've grown, and we're continuing to grow from the site's inception. So why is this important to us? Well, everyone wants traffic to their website, but our revenue is advertising based, so obviously the more users and the more engaged they are, the more page views, the more advertising contracts, more money, and who doesn't want more money? So how can we achieve those higher traffic goals? There are a couple low-hanging fruits that we went after, and one was to increase our engagement on social media, and the other one was to increase the installs of our mobile application Team Stream, which is really popular. So we wanted to increase social engagement because when people follow one of our Facebook pages or one of our Twitter accounts, they're seeing content relevant to them. They'll see, the latest NFL stuff, the MLB World Series. So they'll be more engaged with the content. Also, we want to, with showing people the content, we kind of want to personalize it to them. We don't want to show you random stuff. If we do show you like interstitials to tell you to download our mobile app, we don't want to show it to you every single time. We don't want to bug you that much. We only want to be slightly annoying. So when, if these are our goals, we're thinking, are there any tools out there, existing tools that would help us do this, or do we need to build it ourselves? So some of the things that we needed were every impression for that personalization. And then, we wanted to make sense cost-wise. And I just, here's a pricing page from like an A/B tester. So the top one that they sort of advertise is for $360 a month. You can have 200,000 users. But as I said before, we're almost a couple magnitudes of order higher than that, and using something like that is almost cost prohibitive. We also wanted to be able to customize on a whim. We iterate really quickly, so we didn't want to have to wait and put in requests for third-party companies to take in our requests. So the conclusion came that we needed to build something. And of course, after you know that you need to build something, the second hardest choice is, what are you going to name it? We decided to go with Prism because the NSA had that awesome analytics program, so we just kind of decided to take that name and run with it. So at a very high architecture level, this is what it looks like. We have the Bleacher report applications send data to a node service, which then sends the data to AWS. It gets really complicated, and I'll get into specifics later. I started this project last summer in 2013, and we launched the first portion of it in October 2013. When we started out, we didn't build all of this at once. We decided to go after the conversion piece first, because that was the first piece of our puzzle. So when we're looking at conversions, this is kind of what the people in our company are looking at. Here's a pop-up ad to a Facebook account of ours. This one says follow the World Series on Facebook. If someone saw follow World Series news or follow Bleacher report, changing that copy, would that affect how the number of conversions? Yeah. So I'm going to talk about the conversion piece a little more in depth now, which is, again, that first portion of the diagram. So that's with DynamoDB and Redshift. So Redshift, if you're not familiar with it, it's Amazon's sort of data warehousing solution. And that's where we store all the data, and we run our analytics queries, and it's very like PostgreSQL-like. And then we use DynamoDB in front of that for the scalable writes. We can write to it really quickly. And then one of the only ways to get data into Redshift is through DynamoDB. We did choose, and DynamoDB is Amazon's NoSQL key value store. We really like these two pieces of their data storage because they're both fast, they're both scalable, and most importantly, they're fully managed. Again, a team of one, so if I don't have to monitor and build up clusters and stuff, that's awesome. With that implementation of using Dynamo and Redshift, that had a couple of challenges for us. The biggest one being that, yes, you can get data into Redshift from DynamoDB, but the unit of transfer is an entire table. So you can't just keep pushing data into DynamoDB into one table and say, hey, just copy over the last day or copy over the last hour. It has to copy over your entire table. So to get around that, I had to write some script that would every 10 minutes create a new table in DynamoDB, copy the old table from 10 minutes ago, and just constantly do that. So every hour we have 6 different tables that we're writing to, and every 10 minutes we're pushing 10 more minutes of data into Redshift. So our real-time analysis has a 10-minute lag, which is real-time enough for us right now. Another thing with DynamoDB is that you have to specify the read capacities and the write capacities, and we're just writing to it now primarily. But you do need to kind of fine-tune those so you have enough capacity. You can over-allocate, and that's fine. You're just paying a lot more money. And then an interesting thing after this, 2 months and 1 month, at reInvent last year, Amazon announced Kinesis, one of their analytics tools, which I think I could kind of cut out this transfer script and make it a little easier to get data into Redshift. But this was already built and working, so we stuck with what we have, and maybe when I get back, I'll look into that. And then finally, with putting everything into Redshift, the biggest challenge there was our copy programmers and our analytics people. They don't really know PostgreSQL that well, so they needed some kind of interface. I got to put in a plug for Librato. This is kind of how we are monitoring our read throughputs, our write throughputs. Like I said, or Joe said, we've known each other a long time. I think as soon as they launched this Librato metrics product, he's been bugging me, hey, you should start using metrics, you should start using metrics. I'm like, whatever, I don't need it. Finally, in May, I started using it. I was like, whoa, this is really helpful. And primarily, it's dealing with CloudWatch data and the way that I implemented the DynamoDB tables. So the green line at the top is the throughput that I allocated. It's like 300 writes a second for this table. And then the blue, like really choppy lines, those are individual lines for every single table that I created. And this is over a 24-hour period, that every single table that I created for each 10-minute increment. So you see, like, another thing to add is that CloudWatch, I think we're on the free account, so we only get 5-minute resolution. And if our tables are only there for about 10 minutes, you get a lot of like, oh, they have 0 real throughput, and then they have a spike, and it's not very easy to actually tell what your throughput is from the CloudWatch metrics. So I was able to push my own data to Librato and look at the throughput, and then the red line is actually the percentage of my allocated throughput that I'm using. So I can kind of know, like, hey, when that red line starts getting really high up, I have to increase the throughput on my tables. So now we have the data, and we're transferring it to Redshift. I want to point out some interesting thing. This is kind of, a 24-hour period, and that little spike at the end at 8:30 is when the Game 6 got out last night. So we got a huge surge in traffic to whom we were showing Facebook-like requests to them. So we have the data. I built, some small interfaces. I'm not like a really good UX UI person, so this is bare minimum. We have a couple different views. This is an interesting view that like our analytics people would look at, sort of like a summary, like, oh, for this NBA, that is going to the Bleacher Report social account. We've had that many impressions, and the promo text that was shown was kind of our default promo text of just like follow Bleacher Report on Facebook. You can see that, like for the NFL, some of the copy programmers had put in some custom text to show, hey, follow NFL news versus seeing follow NFL on Facebook. So I think the copy people are the ones who kind of look at this data, and it's been really successful for them. This is from Google Analytics. This is our conversions. I started in July, or I guess that's probably June or something, but we didn't really care about conversions. We didn't really concentrate any effort on increasing social conversions until about August. I think we had a team that was like, hey, maybe we should try to drive traffic through these conversions. So you can see August through, the first arrow to the second arrow, we got a big increase, but then it kind of stabilized. Soon as they had access to data that was showing them what copy was doing well, you can see that we're constantly increasing our social conversions. So, and then that little red arrow is February 3rd, which was the day after the Super Bowl. Again, when we get a ton of traffic to look at post-game analysis. So now that we had the conversion piece working and running very smoothly, we wanted to start looking at how we could better personalize the Bleacher Report experience. We want to be able to recommend tags, like I showed, those are tags, NBA, NFL, MLB. We want to be able to recommend tags to their users based on maybe their prior activity. Currently, it's based on their prior activity. And we also, like I said before, want to be able to control the pop-up frequency. So we can say, like, every 5th time you visit us, we'll show you a pop-up. So we're not that annoying. Again, this is kind of an example of how we would use this. If you're not signed up or logged in, or if you don't have any favorite teams, those are in the red boxes. For like this team stream module, we'll just show you something like based on your location. So we're in San Francisco, we're showing you Giants, 49ers, Raiders stuff. That's cool, but what if you're a Red Sox fan and you're in New York City? You don't want to see all that Yankee stuff, and if you do, you might not come back to our website. So we definitely want to be able to personalize the user experience that way. So to be able to do that, we had to add a couple more pieces of AWS's service into our architecture, primarily S3, and then Elastic MapReduce, EMR, and then kind of to drive that, the data pipeline. And then it all kind of wraps around to use DynamoDB again. So kind of the way it runs, we have all this impression data in Redshift already. We'll run a query, and that dumps it to S3, because you can't really output from Redshift to anything other than like S3 or a text file. Then we'll spin up an EMR cluster via the data pipeline, which will read in the data from S3, do some more transformation on the data to get it back into a format that we can insert into DynamoDB. Let's see. And we do need DynamoDB, again, because of their fast read capabilities, because we pretty much hit these tables on every single page view in Bleacher Report. So just like at a high level, here's like the coffee script in a cron job that runs once a day to sum up For instance, the activities for users over the last month. We create the Dynamo tables. We create some S3 directories. We upload a Hive script that tells the EMR cluster what to do. Then we run the Redshift query, which then puts it into S3. We upload a pipeline definition for the data pipeline, which then will kick off the EMR cluster. And just to kind of show you some of the code that goes with that, this is the query that we run on Redshift. Get the user IDs, the tags, and the counts, group them, and then unload it into an S3 bin that we've created. Then after, we have this pipeline definition, which the most important things are we have a start time, and we start this analysis in the morning, early morning. The second column is kind of the key values that are specifying what type of clusters we're spinning up, and then the last column's kind of showing, telling like with script URI, where the Hive script is and how to do that analysis. And the Hive script, kind of looks like this. It creates internal links in the EMR cluster to the S3 bins and the DynamoDB tables. The bottom is like SQL stuff that does the data transformation, and then it all writes it back to DynamoDB. So what does it look like in DynamoDB? It puts it into a table where the key is a user ID, and these are all completely randomized. We can't trace it back to a specific user account. So user ID and then what they've looked at in the last month. So for instance, well, the one in yellow, they've looked at one golf article in the last month. The one below it, he's interested in the NBA. He's looked at 4 NBA articles, 4 MLBs, 2 NFLs. So we know when he comes to the site again, we might want to show him some NBA articles. Another Librado graph that kind of shows how this, how that whole process works. The green line that kind of looks like that, that's when we start off the, that pipeline where we create the DynamoDB table, and we create it with a low read frequency or read capacity. Then for the first flat portion of it, that's when that whole job is running, where we do the Redshift query and then the EMR stuff, and then writing back to the to that DynamoDB table. As soon as that line spikes up, that's when we increase the DynamoDB read capacity to a production level, and then it flatlines after that to our read capacity. And then you can kind of see this blue line that around 10 a.m., that's when we start reading from that table. It goes from a 0 throughput up to production level throughput. And again, we have a red line that shows us the consumed percentage of our read capacities to sort of alert us. I guess in the future, it could alert us when we're getting too close to our set throughput. Currently, we don't have alerting on that because it's a composite metric, and I'm waiting for Librado to implement alerting on composite metrics. So we have this nice pipeline, we have data, and internally we are doing some testing on new features, new UIs that will integrate this data. So it looks really promising. Just based on what we've done, with all the data that we do have, we can build maybe more accurate traffic representations. Like all those numbers that I showed before were from Google Analytics. And Google Analytics doesn't keep track of all your traffic. It samples, and then it makes inferences on how much they, using some algorithms they estimate your traffic. But since I have all the raw data, I can actually say, oh, how many unique users have visited our website on this day? And when I do compare that to Google Analytics, I do see higher numbers. So, it's nice to see higher numbers. So we will definitely be looking at what Prism numbers are compared to other third-party services. Another thing that we're going to start looking at is automated A/B testing for the copy. So instead of only being able to iterate one type of copy at a time, some of our copy programmers will be able to enter like 4 different types of copy. We'll simultaneously show all 4, pick a winner, and then only show that one from then on. And that takes out a lot of sort of manual work that the copy programmers will do. And then, like I said, I'd like to start investigating Kinesis and what they can do for us, and maybe cut out some of this like scripting stuff I've put together. So finally, I hope from this talk you've seen that AWS's data stores and analytics are pretty powerful tools. It almost feels kind of Rube Goldbergian how you have to piece them all together to get what you want. And if you read the documentation very carefully, you could probably do what you want to do, though there's a lot of wrong things in the documentation too, so watch out for that. Based on our conversion data, we've been able to get significant business value from tracking the conversion copy. And then finally, with all this click data, we hope to be able to offer a plethora of personalization to our website for our users to increase their engagement with our website. And that's all. So if you have any questions, I'll try to answer.
Any questions? Queries, comments?
Do you have any problem with the search engines emulating browsers and spiking your site and jacking up your rates? Have you ever noticed that?
I'm not sure for like in the Google Analytics data, but from the data that I've looked at in Redshift, we don't seem to have that issue. We don't have like all these like random rogue links, and I think we don't allow some of that. When we copy data over from DynamoDB, we don't allow some like random text stuff to get copied over.